Okay, so again, I'm going to go over the slide, and hopefully this will help you a little bit to understand the different types of loops. So this one actually is from a different textbook, just because I think the examples they use in that text is a little bit clearer than the one in the book, so I'm using this for now. But the slides are available on Blackboard, so you can download and use that as well. So we need to define a few terms. And we'll also look at the different types of loops, especially the do loop and the do while. And also some terms in terms of like counters and accumulators. And also another word called prime or priming and so on. So the first thing is what is a repetition structure or a loop structure? Okay, a loop or repetition is the same thing. This is a way of how a programmer used to process some data, some repeating data over and over again. If you don't have a loop in your program, you'll find that it's very difficult and also very time-consuming to write any code to do anything like in this process. Like for example, you want to count how many items in a list, or how many students in a certain age range, right? How do you count those? Instead of just manually doing it line by line, you would use a loop to do that for you. Okay, so this is very handy. I can guarantee you that any program you see will involve one of these structures. Last week we talked about the three types of components that apply to most programs, and that is by using the sequential, right, lines of programming. Everything is run in sequential. Also have the what we call the decision structures, right? The if and else and the select case block and so on, and also the repetition structures, okay, or the loop. So these are the main three components of any program that you will write. Okay, so the loop contains a condition, okay, just like the control structure we talked about last week, the if, else, and the select case also have a condition to test, and if the condition is true, so it will do something, right? So the if and else block, as well as the select case, you have a loop, you have actually a condition to test, and then that condition only be tested once, right? You only do it one time, it runs it once, and either that is true or false, then you can go left or go right, and that's the end of that. Okay. So what the loop here is that you will actually come back to the same condition and then test it again. You keep doing that. You keep testing the condition until that condition is no longer true or no longer valid. Then you can exit the loop. Okay. So an idea would be like if you want to count from 1 to 1,000, then you would do that 1,000 times until that counter reaches 1,001. Then it breaks out of the loop. Okay. So that was the loop is used for. So you have a repeating set of instructions inside the body of the loop. Okay, we'll see that how that works in a minute. Hello. So we have a looping condition. Okay, this is the requirement for the repeating for the instructions that is repeated inside the loop. And then, so we also have a way to also exit out of the loop, because if you don't stop, if you don't get out of the loop, then what you encounter is something called a infinite loop, or a never-ending loop, or we call it just a I think that's the term is the infinite loop. And that will run into a problem, because when you run into that type of situation, then it will consume your system resources. It will eventually freeze your system, and you have to shut down your computer. Okay, so you have to have a way to get out of the loop, and to exit out of that. Then I'll show you in a minute later is how you can force a loop to stop by using the exit command, or forcing the condition to be false. Okay, so just remember that you have to have a way to exit out the loop. So a priming read. So when you set up your loop, you have to prime your read. What this means is that you have to prepare the loop to start at a certain value, right? You can't just say count something and then it just happened. You have to say count something from to 1,000 from what number, right? So that initial bless you. So that initial number or a value that you start from is the priming read. Okay, so when you print something from 0 to 1,000, then you will set the prime read to 0, and then the condition to break out of the loop is when that prime counter is reached at 1,001. Okay, so a primary initializes loop. Okay, the word initializes here. You see that it's pretty common in any application. Where initializing means you actually set up the default values for any, not just the loop, but for any variable you set up in your program, right? So when you did your payroll application, you initialize all the total pay, overtime pay, and regular pay to 0, right? That's initialization. You set it to a default value because those values will change in the body of the code. So primary read initializes the loop's condition by giving that first value. If you want to test whether a number is larger than a certain number and you want to keep reading that list until that number is greater than a certain number, then that is the first value. That first value read into the loop is the priming read. Okay? And then as you go into the body of the loop, so inside the block of code, it's called the body of the loop, then you also want to update that read. If you don't increment or decrement, depending on which direction you go, if you're counting from 0 to 1,000, you actually increment the number. You're adding 1 to the counter every time until you reach a number that is larger than the maximum to exit out of the loop. If you're going the other direction, if you're counting down from 1,000 to 0, then you also want to decrement the counter. And each time to the body, you want to, -1 or minus how many ever steps you want to choose to loop through that until it reaches a negative number or to the loop is false to exit out of that loop. So we have a counter and accumulator. Okay, so a counter is usually a numeric variable. Okay, usually it's an integer because when you count something, you usually count in whole numbers. It's possible to use a counter as a decimal number, but that's kind of rare. Okay, so usually a counter is always an integer number when you count from 1 to a certain number of items, and then you would exit out. Okay, so a counter is used for that, and the counter is usually also included inside the condition of your loop. Okay, so just kind of fun, just kind of understand what these terms mean, and then we'll see some example code later. And then we also have another thing called the accumulator. Okay, this is another variable identifier you can use to store something. So if you want to add some numbers, for example, let's say you have you want to find out the average grade of 5 or of all the student tests in the exam, then you would have some type of accumulator to count or to add all those totals together, right? So you have a counter. Let's say you have 10 students, and so there's going to be a 10 tests, and then you add all the totals to the accumulator. Accumulator is just basically just a variable name. You call it total or something like that. It's fine. And then each time you loop through each test, you add that new test or the test score to the accumulator, and then it keeps adding that until you have added all the 10 exams, and then you can do the average. Take the average out of that. Okay, so that's typical. And then again, the priming is also the initialization part of the prime of the loop. Update, we just went over that already. Okay, so here is one of the loops that is common throughout almost every language you will encounter in your life if you ever go into programming, which you are already. So the while loop is a very common loop in all language. Okay, in the book, I'm not sure if the book talks about it, but if it doesn't, it does have the while loop in Visual Basic. So the while loop you will begin with the keyword while, followed by a condition. It's kind of like the if block. So if A is greater than B, then do something, right? So kind of same thing. While A is greater than B, then do something, okay? So that condition will be the second part. And the condition is always tested at the top. I'll explain what I mean by the top, because there's another way you can also test at the bottom. And there is a so there's a difference between the testing at the top and testing at the bottom. And in Visual Basic, we call those pretest and posttest. Okay, so a while loop is always a pretest type of loop. Okay, so you test the condition at the top before you actually run into the body of the statements, body, and then execute the statements in the body. So the body of the loop contains instructions after the test is tested, true or false, and then at the end of the loop you put the keywords and while, just like the if and end if, right? Sub and sub, function and function. Again, Visual Basic use words, whereas if you learn Java or other languages, you use the curly braces to end or begin a loop or something, a block of code. And then the loop continues as long as the condition remains true. So if the condition is always true, it will keep going until it's false. If there's never a false in there, then it will keep going forever. You have a never-ending loop, which is not good. So here is the a very basic syntax for a while loop. And on the side, you see also the flowchart for that as well. It looks very familiar to you already. You should kind of understand what this is. If you follow the arrow from the top down, you see that whatever comes before it, we don't know, but it's something. Okay, it may be a variable or some type of data that's coming through, and then you have the condition here. So every time we hear the word condition, it's always the diamond shape. Okay, so the if condition, the while loop condition, in the select case, is always a condition. It's a diamond shape. What that means is you always have two outputs, either yes or no. Okay, and that's the only way to also exit out of the loop. So here we have the syntax saying while the condition is still true. Okay, whatever that may be. If age is less than 12 or total is less than 100, whatever that is. If that is true, then you run the statements in the body. So inside here, the statements here is what's called the body of the loop, and you execute these statements here. And the inside here as well, you also want to update the counter. Okay, so that it will go to the next value, and then when it reaches the end while, and it will go back to the beginning of the loop again, and it will repeat the whole process again and again. Okay, so that's what we mean by I say we test the condition at the top. This is the top of the loop, this is the body, and this is the bottom of the loop. Okay, so we always test the condition first before we run the statements. So if you look at this diagram here, you look for a certain condition, you test the condition while this condition is true. Okay, is this true? If it is true, if it's yes, then we will go into the code, go into the body of the loop, like these statements here, execute these statements within the loop. It reaches the end of that loop, the end while, and it goes back to the top again and then test the condition again. Is it still true? If it is, you can see that this loop here, it goes into a cycle, right? Continuously until the condition is no longer true, and then it will exit out, and then you end that loop. Okay, so you have to find a way to exit out of the loop. So here's an example of the code. So priming, it means you again initialize your variables. So we have a counter, a dim counter as integer. We prime it to be 0, or we initialize it to 0, and then you have a total. This is your accumulator, okay, to also 0. You start from there, and in this example, we're just basically going to add the counter number, which is 0, and then from 0 to 10, right? Well, in this case, it would be 9. We add that to the total. So basically, every number we're adding all the numbers from 0 to 9, and then we get the total out of that. So you prime your variables, and then you start with the loop here. So you say while the counter, which is here initially is 0, okay? If this is less than 10, is this true? So in this case, it's true because 0 is less than 10. If that's the case, then we go right into the body of the loop. So line 7 and 8 only have two statements here are inside the while loop, and then we'll just basically update the total to total, which is 0 plus the counter. In this case, it will also be 0, right? So 0 plus 0 is still 0. And then we need to update the counter. Okay, if you don't supply line number 8, and let's say if line 8 is not there, then it reaches line 9, end of the loop, the while loop, it has to go back to line 6 again and test the condition. And in this case, if you don't do that, then the counter will always be 0, it will always be true, and then the total will always be 0 also, and then this loop never ends. Okay, it runs forever because the condition is always true. So that's why it's really important for you to update your counter. You always do that. Whatever you update here has to affect the condition here. Okay, if you update only the total, then because the total is not part of the condition, this will never exit. So you want to make sure that one of the counter variables in here has to be a part of the update here. So if you have while counter is less than 10, and you can say and total is greater than 100, now you have two parts to deal with, right? So in that case, it's possible that total could be the part that caused this code to break or not, depending on how you code it. And then once the counter reaches 10, and then because 10 is no longer less than 10, then you exit out of the loop, and then you're done. And the total will have a value of all the numbers from 0 to 9 added together, and then you will just output that to a message box. Okay, so this is a typical while loop. It will look very identical in most languages. Okay, like in Java, C, C++, JavaScript, PHP. Okay, they all look very similar, except you don't have the word and while. Okay, you would say while counter is less than 10, put a curly brace here, and then at the end you put a curly brace to close that. Okay. So a pretest and a post-test loops. Okay, so the while is a pretest because we say pretest means we test the condition at the top of the loop. Okay, at the very top. So a pretest, or we sometimes call the top control loop, is that when the condition is tested at the beginning of the loop. Okay, you test the condition first before you actually execute the body of the loop. So if the test is already false from the beginning, then all the statements in the body will never get processed, and you just don't run any of the code inside of it. So the whole thing just bypassed. Okay, and so here, depending on the result of the test, okay, this is the loop may never be processed, because initially, if that condition is already false, then nothing is run, and then it's never guaranteed that the code will run. A post-test is when you have the condition is tested at the bottom of the state of the loop. So when you test the loop at the bottom, then you will run the statements at least one time, and then you will test at the bottom. So that means that because we test at the bottom, whatever is written inside the body of the loop will execute one time, guaranteed every time. Okay, so one time will be executed, whereas the pretest it may not. Okay, so that is the main difference between the two, and we'll show you what that means in a bit here. So here's a pretest, right? This is called a do while loop. Okay, notice that in the previous test we don't have the word do while. It just says while something, a condition, and then we have the end while. Okay, this is called a do while loop. What you see is the keywords do while. Okay, and then you put the condition in right after that, and then the body of the loop, and then at the end of that do while loop, you don't see the word end do while. Okay, you just see the word loop. So loop means it just go back to the top here, and then do the test again, and then execute the body of the loop again if it's still true. Okay, so a pretest while begins with the keyword do while here, and then the condition followed by the body, and then of course you have the loop at the end to end that loop. Okay, so here is an example again what we saw earlier, except now it's a do while. But if you look at the flowchart, it's the same one, right? Exactly the same as before. So a do while and a while loop, they pretty much look exactly the same and work the same way. So you can use either one. You can say while the condition is true, do the body of the loop, and the end while. Or you can use a do while. Do while this is true, run the body of the loop, and then you would loop, and then you get that. So those two work exactly the same way. Okay. So if you look at this, so here's a way how you can use a do while loop to test some scores. Okay, so we prime the int score as an integer to start at 0, right? Initialize it, and then so in this case we don't really have an accumulator. So in this example here, the accumulator is also like int score, but we don't have anything here. We're not adding, storing anything here other than just updating the int score, which is the counter in this example. So initially the int score is 0, and we'll loop through this int score on, all the way from 0 through to 5. So 5 is not inclusive, that means 4, right? So when it reaches 5, then it will exit out of the loop. And the table below, you see something called desk checking, or sometimes referred to as hand tracing. This is a manual way of how you can actually use to debug your code, okay, or actually trace the code by hand. And you'll see that sometimes it's really helpful, especially if you run into a problem, a code problem that you cannot understand why it's not working the way it should. When that's the case, then you would use a desk checking method to manually check the values of that loop to see where things are. And maybe somewhere in there in the body of the code, something is incorrectly coded. Okay, so for example, in this case, if you loop to the first condition, okay, the first loop here is we set the int score to be 0 because we primed it to be 0. And you test the condition here, so the loop number of loop, the first loop, the int score is 0. The result of this condition here, okay, this is true because 0 is less than 5. Okay, that is true. Then we run the loop, bless you. And then we now increment the int score to 1 now. So we go back to line 18, and so loop number 2. The int score is now 1. Is 1 less than 5 is true still, so we run the loop, and then we add 1 to int score, that's now 2. So loop number 3, we test the condition, is still true. 4 is still true when int score is 3. 5, loop number 5, int score is 4, is still true until we go to the 6th loop. Then int is now 5, and so therefore 5 is no longer less than 5, it's false. So this loop iteration number 6 here actually never get executed because we don't go into the loop anymore. So we exit out of the loop. Okay, so it's false. So when we do desk checking, when you do hand tracing, you would use a chart that looks something like this. Keep track of all the variables that is part of that loop, and then check each values as you trace the loop through it. Okay. It's really helpful sometimes. Okay, so so that was the pretest. Again, pretest means you test the condition in the top. So now is the post-test, which is the opposite of the pretest. This is also called the bottom control because you put the loop, the condition at the very bottom, as you can see here. Okay, so you basically you remove the while condition and you just, move it to the bottom after the word loop here. Whereas the other one, you keep the while condition, attach it to the do on the top. Okay, that's all you do. But it's it gets a little bit tricky because you want to make sure that condition is test at the bottom. What this means is that because there's no condition on the top of the do loop, so if you have any statements inside here from the do all the way down to the while loop here, then all those statements will run one time. Okay, because there's no condition to test. So we'll treat this as just a regular statement from here all the way down until you run to the loop here, and then it will test the condition, and then it will know where to go. It will look for the closest do, which is this do here. It will go back up here and repeats the code from here again. Okay, so it's similar. You test at the bottom. You just put the word do there. You don't use the while, and then you close it with the while at the bottom, and then followed by the condition loop and then the while condition here. Okay, so here's an example of that what we saw earlier. Again, the flowchart will look just exactly similar, except now we swap those two shapes. Okay, so the diamond is at the bottom, whereas before we had the diamond at the top. Okay, so this is a post test or a bottom control type of loop. Let's say do. That means, as you can see here, there's no conditions to test here. So we will run the code here one time, whatever those codes may be. If it's a single line or 1,000 lines, doesn't matter. It will run all of them, and then we'll test the condition at the bottom of that loop. And then if it's still true, then it will go back to the do part here, and then it will execute again one more time, and then hopefully that you will update your counter. Okay, and then it will test again until it is no longer valid, and then it will stop. I think it's an error here because is the condition true, right? So if this should, I think this should be say yes. Okay, so I think I got this from the book, but so this should be say yes, it should say no. If it's yes, then it will need to go back. Otherwise, no, it will exit out. So that's an error here. Right, so the same example as before, the end score. So now we test at the bottom. So we prime the end score to 0. So the loop, the death checking. So initially, the first loop is you get a score of 0. End score is 1. Okay. So notice that initially it was 0, and then inside the do and the body, we increment that by 1 already. Then we'll test the score at the bottom is 1 less than 5. That is true. So we go back and do it again. So the second time is now the end score is so after with this, end score is actually 1, but in the body we increment that by 1 already, so end score is now 2, and 2 is still less than 5, and then we keep doing that until well, it doesn't show the rest, but until the end score is 5, and then we exit out of the loop. Okay, so if you look at this very carefully, it's a little bit different. It's quite different from the previous one. Okay, because initially we start with 0, but then we already add 1 to it right away in here, so now it's 1. So we never get to test the 0, right? Because we run these statements first. So here is a comparison of the two, how they are coded. If you look on the one on the left is the do while. On the right there's another loop called do until. Okay, both of these are similar, but they can be really tricky because one actually is the reverse of the other. Okay, so the one on the left, it says the while loop. It says do while condition is true, then you run the body until it's false. On the right side, you say do until, right? Do until something is false, and then you run the code. So it's the reverse of the other one. So if you want to code this, you can say do while number is less than 5. While that is true, then run the code. On the other side, you say do until number is greater than 5. Okay. So so the condition is opposite of each other. You can use either one, But just to make sure that the condition is properly coded, otherwise you will get a expected result. So the do until loop, this is only I think available in Visual Basic, like C and Java, and most other languages do not have the until condition. So usually just have the while and then the do while loop, but not the do until. And they added another one here. It's just a little more confusing. So likewise, you have the top control on the top, and you have also the bottom control at the bottom for those two type of loops. You have the do while, and then the do loop bottom control, and the do until, and so on. Okay, so those are quite different. And here's another diagram to show you the difference between the pretest and the posttest. You see that both of them, the diamond shape and the statements are reversed. Okay, for the posttest and pretest. So you test the condition at the top first before you run the code. So if the condition is false, therefore it's never guaranteed that the statements here will be run or will be executed. So it may never be executed because the condition is always false. Okay, but on the other posttest loop, it doesn't care what the condition is may be. At one time, it will run the code one time. It tests it down here. If it's false, then it will just exit out. Okay. Again, I think the wording is wrong here. It should be yes and no here. So, an example here is what's called an infinite loop, or a never-ending or forever loop, is where the condition is never set to false. It never gets false. So therefore, this will keep running until it uses all your system resources, or until you actually physically just explicitly shut down the application, or shut down your computer and reboot your system. Okay, so I have to be really careful when you write your code with the loop. So this example here, there's no way of for this condition to be false, because int problem is 0. It's always going to be less than or equal to 5, and in the body we never really update the int problem variable, so the counter never reaches 5 or above, and therefore it never stops. Okay, so this is an example of an infinite loop. This one is pretty short and small and easy, but if your loop gets pretty big, then sometimes you can run into this problem. Okay, so be really careful. You can also have nested loop, right? Just like in your nested conditions, you can have it so that it's nested inside one another. So here we have the two counters, one for the inner, one for the outer. Okay, just make sure you use separate counters. If you use a single one, you will have a conflict, and there might be a problem. So you can use so you prime these two variables to 0, and the first loop is you check whether the outer loop, the outer is less than or equal to 5. If it is, in this case, yes, the first time around is 0, so that's less than 5. And then you go into the body of the outer loop, and then inside the body you have another inner loop, and then now you test the inner variable, and if that is less than or equal to 10, then you increment the inner loop. And then so now you run the inner loop first. You run this inside loop until it's false. It runs 10 times. In this case, probably 11 times because 0 included. And then you exit out, and then the outer loop is +1, and then you run it again inside, and then you run it again inside. But since we didn't reset the inner variable inside here to 0, so this will only run one time. Okay, so when you run outer loop is 0, inner is 0, you go inside here, inner is 0, yes, true, then +1, +2, all the way to +10, +11 is false, exits out, and then outer now is 1. You go back and run the loop again, it's 1 less than 5, yes, and then you check the inner, because inner we already run it one time, and inner is already 11, so this is false, so this part never gets run anymore, it's done, and then just do the outer loop 5 times, 6 times, and it's done. Okay, so be careful if you want to run this again 10 times, and somewhere in here you have to reset the inner variable to 0 again. So like right around here, do while outer is less than 5. That inside here, you before the do while loop, you want to say inner is equal to 0, and so it will run 10 or 11 times. Okay, so be careful when you have this inner or this nested loop. And anytime you can also force a loop to exit by using the exit statement here. So here is, let's just say you don't have to do 100 times. If let's say you want to count from 0 to 100, and let's just say I want to stop when the counter reaches 20. If that's the case, then you put the keywords exit do, and then that will stop the loop right away at 20. Okay, so from 21 onward, it will not do that anymore. It will exit out of that. It will force the loop to stop here, and it will jump out of the loop and execute the next statement here below the loop, whatever that may be. Okay, so you can force it to be this way. Sometimes you might have to do this because, let's just say, if you want to look for a certain number in a long list of data, and if that data has been found, then you don't need to look in the loop anymore, right? In the list anymore. So why would you want to spend, that so many time to run the loop because you already found what you needed? So in that case, you just exit. Okay. So that's one of the conditions there. Just showing you the difference between the while and the do while. As you can see, they look very similar, and they work exactly the same way. So the difference is just the keywords. You have the while and end while versus the do while and then the loop at the end. Okay, but the coding is exactly the same. Okay. Okay, so I'm going to go and then do some examples so we can do this together as well. Run a few of these loop, and then we'll continue on with I have some something about the input box, and then also have something about the select the list box, which we already went over last week and the week before. Okay, so let's go into our Visual Studio and let's create an application, a project, and we'll do some of those loops.